Question 48 says what are the lengths L and the width W of a rectangle with perimeter 10,000 meters that maximizes the area of the rectangle, it says. So the given is the perimeter of the rectangle. We need to find the length and the width that maximizes the area of this rectangle. So we know that area is length times width, and it is given that the perimeter is 10,000 meters. So perimeter equals the length plus this length, which are equal, plus the width plus again the width, no? So this will be 2 times the length plus 2 times the width ይሆንልናል. So it is given, this one is 10,000 meters, so this will be equal to 2 times L plus 2 times W. So from this equation we can obtain an equation that expresses W in terms of L. So if we divide both sides by 2 and subtract W, then we get L equals 5,000 meters minus W. So we take this as first equation. Second, we have the area formula. So the area equals length times width. So in this case, length is expressed in terms of width, so we can write 5,000 in place of length minus W in bracket times W እናገኛለን. So this gives us 5,000 W minus W square. So this is the area function in terms of W. We have to find the length and the width that maximizes the area. So we need to find the critical numbers. To maximize the area, we need to find the critical numbers of the second equation. So what are the critical numbers? The critical numbers are obtained when the first derivative of the area function in terms of W equals 0. We find the first derivative of the area function. A derivative at W equals the derivative of 5,000 times W minus W square, the whole derivative. So the sum of two functions, f and g, plus or minus g, derivative, we can write the separate derivative and we can add or subtract them. So by using this, we get 5,000 W derivative will be just 5,000 because W derivative is 1 and 5,000 is a constant. W square derivative is just like x square derivative. In this case, we get 2x. ስለዚህ እዚህ ጋር minus አለ 2 times W ይሆናል. This should be equal to what? 0. To find the critical number. So solving this equation will give 2 times W equals 5,000 ማለት ነው. So W will be 2,500 meters. Now we can go back to the first equation to find length, which is 5,000 minus 2,500 for W, which will be 2,500 again. So our answer that maximizes the area are 2,500 by 2,500. ይህን ጥያቄ ምርጫዎቹን ብናያቸው ለምሳሌ ቢ length 2,500 ይላል width ደግሞ 3000 ይላል. So if the width is 3,000, 2 times the width is 6,000, 2 times the length is 5,000. ስለዚህ ይሄ ከ10 ሺህ በለጠ because it is 11,000 ይሆናል. ስለዚህ ከዚህ ጋር ይቃረናል፣ መልስ አይሆንም። Similarly እዚህ ጋር length 3,000 ይላል and width 2,500. ስለዚህ ይሄ በቀላሉ መልስ እንደማይሆን እናውቃለን፣ ምክንያቱም ፔሪሜትሩን ብቻ መፈለግ ማለት ነው። ምክንያቱም ፔሪሜትሩ የተሰጠን 10,000 ነው፣ ነገር ግን እነዚህ ፔሪሜትር የሚመጣው 11,000 ነው። ቾይስ ዲም ካየነው ፔሪሜትሩ የሚመጣው 20,000 ነው፣ የተሰጠን ፔሪሜትር ግን 10,000 ነው። ስለዚህ በዚህ መልኩ ራሱ ኤሊሚኔት አድርገን ከቢ እስከ ዲ ያሉት አይሰሩም። ስለዚህ ኤ ነበር የሚሆነው ማለት ነው መልሱ።
So if you consider these three rectangles for the area maximization problem, you can see that the perimeters of these three rectangles is 10,000 meters. For the first rectangle, so 2 times the length plus 2 times the width will give 4000 plus 6000, 10,000 meters. But the area, the region enclosed by this rectangle is length times width. So it will be equal to 2000 ሲባዛ በ3000 6 million meter square ይሆናል። 6 times 10 the power of 6 meter square አድርገን መጻፍ እንችላለን። Let's say for the green rectangle, length is 4000 meter and width is 1000 meter. So perimeter will be 2 times the width, 2000 meters, plus 2 times the length, it will be 8000 meters, and it will give 10,000 meters. So perimeter is the same as the first rectangle, which is given by the question. But the area, if you calculate the area, length times width, 4000 times 1000, it will give you 4 million meter square. That means 4 times 10 the power of 6, 4 million meter square. You can compare the area of the first is 6 million and the area for the second is 4 million. So the first rectangle is greater. With the same perimeter, the area is greater. So if you consider the third rectangle, which is a square, እኛ ያገኘነው 2500 ሜትር በ2500 ሜትር ሌንግዝ እና ዊድዝ ያለው ኤሪያውን ካልኩሌት ብታደርጉ the area will be length times width. So 25 times 25 is 625 times 100 times 100 is 10 the power of 4, which is 10,000. ስለዚህ ሁለቱ ስታባዙ ይሄኛው ወደ ኮምፔር ለማድረግ እንዲያመቸን 6.525 ብናደርገው 100 አለን እዚህ ጋር። ስለዚህ 10 the power of 2 plus 4, it will be 6. So you can see that the area for this rectangle, for which the perimeter is the same, because 4 times 2500 ማለት 10,000 ነው። So the maximum area that we get for this rectangular region with perimeter 10,000 meters is 6.25 times 10 the power of 6 meter square. So that means the maximum area is obtained when the first derivative of the area function is 0. That means at the critical numbers ማለት ነው። For a given function f defined on the closed interval from a to b, if it is differentiable and if the curve is continuous, then the maximum and minimum values are obtained, which means the extreme values ማለት ነው, are obtained at either the end points, that means either at a or b, or at the critical points. The critical points are the points where the first derivative of the function is 0 or when the first derivative doesn't exist. ስለዚህ maximum እና minimum value, extreme values የሚገኙት either at the critical points or at the end points of the ይሄ የካልኩለስ application ነው። ለምሳሌ ይሄንን function ብናየው you can see here that relatively this is minimum point, this is relative minimum point, this is relative maximum and also ስለዚህ ከነዚህ ፖይንቶች አወዳድረን ነው። So at this point the first derivative becomes 0 because the tangent line becomes horizontal. እዚህ ጋርም እንደዚሁ horizontal tangent line እናገኛለን። እንደገና ደግሞ ኢንድ ፖይንቶቹ ላይ ያሉትን ቫልዩዎች f of a again f of b ካልኩሌት እናደርጋለን። ስለዚህ እነዚህን ክሪቲካል ፖይንቶች ካልኩሌት ካደረግን በኋላና f of a f of b ካገኘን and after calculating the value of the function at the critical points, all these points, then we can decide the maximum and the minimum values of the function in the given interval.